Good day, grade 9 science students. Today you just saw some examples of static electricity. Today we're going to take a little bit farther. We're learning about something known as conduction and induction. And we know a little bit about static electricity already. Good day, grade 9 science students. Today we just learned, or we just saw some examples of static electricity. And we're going to learn about how these things actually work. We know a bit about static electricity from the previous video and in class. Today what we're going to do is we're going to learn that there's different ways that we can use or transfer static electricity through friction, contact, and induction. And we're going to learn today specifically that about conduction and induction. Okay, so the real three things that we need to know about is friction, contact, and induction. That's how we can charge things, but today we're just focusing on contact and induction, or conduction and induction. So at the beginning of the first video we just saw an electroscope, and an electroscope is an instrument that can be used to detect static charge. And the study of static charges is called electrostatics. And I want you to remember or know that electrons can move, protons cannot. This is important. Write this in your notes, and I know it's not there, but protons cannot move because they're in the inside of the atom. Electrons can move on the outside. The electroscope was first invented in 1748 by a Frenchman physicist by the name of G9ScienceContactLesson12, and they can change their shape and appearance depending on the charge that's around them. It can really tell you what charge is there. So it has these little leaves, metal leaves at the bottom, and they change how they are located in space, and that can tell you the charge on a given item. So if I bring the item close to it, I can look at the electroscope and I can tell what the charge on the item is. So detecting static charge. When a charge rod is brought close to an electroscope, it creates a movement of charge called charge separation. So you can see if we look at this charged rod right here, if we count up the number of electrons it has 5 negative charges and 3 positive charges. So that means it's got a negative charge. And what happens is the protons can't move, but the negative charge on this rod pushes the electrons down the electroscope and into the leaves. And as it gets pushed down, these electrons get pushed down, the leaves gain a negative charge, and we know that negative and negative repel each other. So if we look at this, this is another way of showing this, and I'm going to want you to draw this down. You have a negatively charged object, and what will happen is as you bring it close to another object, the protons can't move, but the electrons move away from the negative charge because negative and negative repel. So when we take that negative charge away, what happens is that those electrons no longer are pushed down into leaves. They move up back into and distribute themselves equally throughout the electroscope, and it's neutral again. So the leaves just fall back into place. So we have something known as charging by conduction. And electrons can be transferred through conduction or contact. So conduction, remember, means contact. So if we want to charge a neutral object, what we can do is we can bring electrons close to it. And you see initially, right before I touch it, the electrons move away. And as soon as I do touch it, the electrons will actually get transferred from the object to the sphere here. And this is known as conduction. As soon as I touch, those electrons move into that object. Okay, so electrons can be transferred through that conduction. So when we charge a neutral object by conduction, the electrons move into that object. So here we have a metal sphere with a negative charge. It's brought close to an electroscope. You can see that the leaves are just falling straight down. And what happens is the electrons will move into that electroscope. And as that happens, those electrons will move evenly throughout the electroscope, and that electroscope will take on a negative charge. And because of that, again, the leaves will spread, and that's what we're seeing in this last slide. So here we're charging a neutral object by conduction, but now we're bringing a positive object close to it. Here we have a neutral metal sphere. It's got the same amount of protons and electrons. We bring a positively charged object and we actually touch it. What happens is the electrons will move into that positively charged object, and then we've removed electrons from the electroscope and we're left with a positively charged object. So whenever you touch something with a negative thing, it becomes negative. Whenever you touch something with a positive thing through conduction, it becomes positive. So when a charge is transferred to the plate or knob, in this part we're talking about the top part of the electroscope, the charge is spread out of over the whole structure. and including the deflection arm, which is down here, or the leaves. And the greater the charge, the greater the separation, the leaves or deflection arm. So here we have a deflection arm where it's separated very far, and here we have leaves being separated. And the greater the charge that we put on that electroscope, the further that they're going to spread apart. The less of a charge, it's going to be closer together. So this is another way for us to tell how big the charge is going to be. So here we're showing a neutral object will gain the charge when it's touched by a negative charge. If it's touched by a positive charge, it's going to be touched by, it's going to gain a positive charge. So here on the left-hand side, right beside my face here, we have a negatively charged rod. It's got more negative electrons. It's got 6 negative electrons and 3 positive charges. It's negative. Initially, when you touch it, before you touch it, the electrons are going to try and push away. But then what's going to happen is the electrons are going to flow into it. On the other side, over here, below me, you have proton or more positive charges. You got 6 positive charges, 3 negative charges. This is positive. What will happen here is the electrons will flow out of the electroscope. And what we'll end up having is we will end up having a positively charged electroscope on this side because the electrons left. And over here on the left-hand side, you get a negatively charged electroscope because the electrons moved into it. So you can see negative object, touch the object, becomes negative. Positive object, touch the object, became positive. In both cases, you can see on this side, what you see that the electrons have distributed itself. After you move the charged rod away from it, the electrons are moved equally throughout the electroscope. And on this side over here, you also have electrons that are distributed equally throughout. And so what ends up happening though is on this side you have more electrons, so therefore it's negative, there's more negative things at the bottom, and on this side you have less electrons, so that means that there's more positive around there. So these leaves are spreading because they're positive, and these leaves over here on this side, they're spreading because they're